For number 192, we're going to need the binomial expansion formula. So we're going to have sigma from k equals 0 to n of n factorial over n minus k factorial times k factorial. And that's going to be multiplied by a to the n minus k and b to the k. So for here, if they're asking us to find the fourth term, it's important for us to understand a few things. N is always the exponent that they give to us. K is one less than the term that they're asking, so k is going to be 3. So I'm going to put this into the formula, so it's going to be sigma from, or summation from k equals 0 to 5 of n factorial, so 5 factorial over n minus k, so that is 5 minus 3 factorial times 3 factorial. A is going to be replaced with x, and that's to the n minus k, so that's 5 minus 3, so 2. And then b is negative y to the k, so that's going to be 3. Alright, so let's figure out the coefficient. That is going to be, looks like 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. 3 times 2 times 1 is going to go away. Those go away. That becomes a 2. So my coefficient is 10, but don't forget, it's being multiplied by, actually, you know what? We can forget about that. It's x squared. Negative y to the third is y to the third, but it's also negative. So that should be your third term right there. All right, let's do another expand. Oh, sorry, yeah. Yep. And so don't worry, y'all. We're going to do another one. We're going to up it a notch a little bit in this next example. In example number 189, they are asking you to find. I'm sorry, that's expanded binomials. I apologize. Let's take a look at, how about 196. So 2x plus 3y to the 8th. They want us to find the 6th term. Yeah. Thank you. Yes, plus 3y. Thank you, Jacob. Okay, so I'll leave it to you guys. What's n and what's k? Alan, do you know what n is? Not 3. N's not 3. Anyone help him out? What's n? Alyssa. N is 8. Alan, the n comes from here, okay? What's k? Skylar. 5, right? One less than the term they're asking. So this is going to be summation from k equals 0 to 8 of n factorial, so 8 factorial over n minus k, so 8 minus 5 factorial, 5 factorial. And that's now going to get multiplied, Yael, by 2x to the n minus k, so that's 2x to the third, and then b to the k, so that's 3y to the fifth. So far, so good, Yael? Okay. So now, let's figure out the coefficient. That's going to be 8 times 7 times 6, 5, 4, 3, 2, 1, all over 3, 2, 1, and then 5, 4, 3, 2, 1. That's gone, that's gone. 3 times 2 is 6, that's gone. My coefficient for now is 56. However, 2x to the third is 8x to the third, and then 3 to the fifth is 243. Y to the fifth. So you guys have calculators. I need 56 times 8 times 243. Kylie, as soon as you get it, please let me know what you got. Raise your hands if you agree with 108864. That's what you get. Yael, you had a question. Eight times 7 equals 56. Am I right or am I wrong? 8 times 7 equals 56? Yes, Yael, you don't agree. Eight x to the third, change colors here. 8x to the third came from here. 243y to the fifth came from here. Yep. Duh. Okay. Let's do another one. Let's do a harder one. Let's do something like number 193. Oops. 2x minus 3y. Wait, didn't we just do this one? We did. I'm sorry. 194. Okay, this one's a little harder. We're trying to find the fifth term of x over 2 minus 3y to the 8th. Okay. Stephanie Boyer, how are you? Good. Can you know what n and k are? 8, k is 4. Good. Okay. Let's find the coefficient. So that's from k equals 0 up to 8. 8 factorial over 8 minus 4 factorial, 4 factorial. Now this time it's a little different because x over 2 is the a, so it's going to be x over 2 to the 4th, and then negative 3y to the 4th. Okay, let's figure out the coefficient here. That's going to be 8 times 7 times 6, 5, 4, 3, 2, 1, all over 4, 3, 2, 1, 4, 3, 2, 1. Gone, gone. 4 times 2 is 8. 6 and 3 are going to cancel. I get a 2. 7 times 2 times 5, that is 35 times 2, that is 70. So I get 70 times x over 2 to the 4th is x to the 4th over 16. And then I get 81y to the 4th. See, these both divide into 2, so I get 35 and I get 8. So I need 35 times 81. 35 times 81. Stephanie Boyer, what do you got? 2835, huh? All over 8, and I get, that's an x to the 4th, y to the 4th. Okay, there goes some expansion problems. Let's hammer out as many logarithm problems as possible. Okay, let's take a look at something like something easy like 75. This is an exponential problem. 3 to the 4x equals 3 to the 3 minus x. The most important thing you need to pay attention to is that the bases are the same. If the bases are the same, what does it mean about the exponents, Yael? You can't cancel out the exponents. What does it mean about the exponents? Kylie. They are equal. 4x equals 3 minus x. 5x equals 3, x equals 3 over 5. What do you think they're going to do to make this problem really, really hard? Change the bases. So, an example of this would be like number 73. 27 to the 2x minus 1 equals 3. I'm going to refer back to that. I'm actually going to copy this problem down because I want to reference this another time. What base do 27 and 3, Jake, what base do 27 and 3 have in common? 3. So does it make sense, Jake, that I say 3 to the 3rd to the 2x minus 1 equals 3? So now, what do I do when I have exponent raised to an exponent? What happens to those exponents? Zoe, multiply them. So I got 3 to the 6x minus 3 equals 3. And 3 is really 3 to the what power? First. So, does it make sense that 6x minus 3 equals 1? Yeah? 6x equals 4, x equals 2/3. Cool. Let's see here. Evaluate each logarithm. Let's take care of something really easy. Log base 2 of 64. This is number 77. What this is asking you is 2 to the what power equals 64? And that's something you just kind of have to know at this point. 2 to the what power equals 64? 6. 79. They're asking you 2 to the what power equals 1/8. Now, what is the only type of number that's going to give me a fraction? Alex, negative number. So 2 to the what power equals 8? Skylar, negative, or in this case 3, but that 3 is negative because we got a fraction here. Okay. Who knows the answer to this problem? Only Yael. Kate, why? Yeah, 5 to the what power equals a negative number. Who knows? Nothing, right? So that's gone. People seem to have a hard time with this problem. This is number 80. So what I want you to do is I want you to put an X right here. So we're stuck. Whenever we're stuck in a logarithm problem, what do? Kaylin, change form. So does it make sense that this becomes 8 to the x equals 4? Now let me ask you guys a question now. Do 8 and 4 have a common base? Jacob, 2. So 2 to what power equals 8? 3. So 2 to the 3x equals 2 squared. Drum roll, what does x equal? 2/3. All right, let's do something a little more complicated, like number 86. Log base x of 2 equals 0. Whenever you're stuck, what should you do? Change form, especially to exponential form. So that means x to the 0 equals 2. What's anything to the 0 power? 1. How often does 1 equal 2? So this answer is, right? These problems, 85 through 93, are relatively simple, like 92. I have a single logarithm that is the same base on both sides. Raise your hands if you've heard me say this before, or in this exact tone of voice. Okay, yeah. I have a single logarithm of the same base on both sides. What can I do with those logarithms that are of the same base on opposite sides, Kylie? Get rid of them. So I have x squared plus 16 equals 80. X squared equals, what is that, 64? X equals plus or minus 8. Now, because I had an x in the answer component of the logarithm, what do I need to do when everything is done? Jake, check. Which one works? Which one doesn't work? Jake, they both work. Why do they both work? Because x is being squared. So if I plug negative 8 in there, it's going to be squared anyway. So both check out. We're good. Okay. Let's see. Something like number 89. I have a single logarithm that are the same bases on both sides. What can I do with those logarithms? Rebecca. They're gone. X minus 1 squared equals 1. Most people are probably going to try and FOIL this out, subtract 1 and factor it. You're not going to get the wrong answer. I prefer to do this because 1 is a perfect square. X minus 1 equals plus or minus 1. Because plus or minus 1 is a whole number and not, Yael, what's with that look? What's with that devious look? No? Okay. 1, negative 1. So I'm going to add 1 to both sides. So I get 2 and 0 as my answers. Because I have a logarithm in the answer component, what do I need to do with my answers? Check them. Which one works? Which one doesn't work? 2 works? 0? 0 doesn't? Stephanie? Yes, they both work because 0 minus 1 is negative 1. Squared is 1. We're good. Okay? Stephanie Boyer. Good job. 94 through 103. I'm going to throw 94 up there. And I'm going to do something that, if I see this happen on the midterm tomorrow, there's going to be some serious bamboo shoots going up people's fingernails. What do you think is going to make that happen? What's the bamboo shoots going up your fingernails part of this problem? Kylie? Yeah, people saying, oh yeah, x plus x minus 2 equals 3. Is that right, or is that bamboo shoots? That's bamboo. Man, that's bad. No, is that bamboo? It is, right? What do I need to do instead? What do I need to do instead? Danny, consolidate. These two logarithms are being added together, which means the answers are being what? Leanne, what's happening to the answers in this logarithm? They're being multiplied. So log base 2 of x times x minus 2 equals log base 2 of 3. Now that I have a single logarithm on each side and they're the same base, now what can I do, Kaylin? Now they can go away. So I get x squared minus 2x equals 3. How do I solve this? Jake. Move the 3 over. X squared minus 2x minus 3 equals 0. Factor this baby out. X minus 3 times x plus 1. X equals 3, negative 1. Done, right? Matthew. Negative 1 is out. Now, in the midterm tomorrow, you have to show me you considered negative 1 as an answer. If I just see x equals 3, you're going to get points marked off. I need to see x equals 3, comma, negative 1 with an x through negative 1. Duh? Did we do 101 yet? I swear we've done that problem before. Yeah? Okay. Let's do something like 97. Okay. What this is not x plus 2 plus 6 equals 3. Don't do that. What is it really? What is it really? Brother. Log base 3 of 6 times x plus 2 equals 3. Hang on for a second. I don't have anything that I can cancel. There's no log base 3 on the other side. If there's no log base 3 on the other side, what can I do with this thing? Stephanie Boyer. Change forms. 3 to the third equals 6x plus 12. 27 equals 6x plus 12. Raise your hands if you know exactly what to do from here. Solve it. Check it. Good to go. I'm not going to insult your intelligence by doing numbers 104 through 115. That's all calculator work. Let's take a look at something like number 116. Now, I'm going to compare it to a problem we've done before. Okay. What is the difference between number 116 and number 173? What is the biggest difference between 116 and 173? Kate. You can't make 12. Well, actually, no. No, you can't. No, you can't. There's no cube root. Okay, yeah, you can't. So, if we can't do that, if there is no way we can make the bases the same, what are we resorted to do? What can we do? I mean, you know, I wish there was a way we could deal with this. Jake, what do you think? Take the natural. Jake, you're the only one who says that, dude. Thank you. I appreciate. I should give you extra credit on the midterm for that. Take the natural log of both sides. You get natural log of 6 to the x equals natural log of 12. What happens to that x that's sitting up in the exponent of the answer? Leanne moves down. X ln 6 equals ln 12. How do I get x by itself? Matthew. Divide by the natural log of 6. Now, who can raise their hand and tell us, what do you think the most common mistake I'm going to see is next? Brother. They're going to think this is the natural log of 2. It is not. Take them individually and get your answer. Okay? Jacob. I don't think so. No. Second? 1.386, yeah. I don't think it's going to be that close to 2. That's all right. Stephanie. Yes, you can, Stephanie. Okay. How about something like number 122? 8 to the 2x minus 5 equals 5 to the x plus 1. No way is 8 and 5 gonna share the same bases. No way! How do I handle an 8 and a 5 brother? Take the natural log of both sides. So I get 2x minus 5, natural log of 8, equals x plus 1, natural log of 5. Okay. How do I deal with it this time? I got to get all the x's to one side. Brother. Going to distribute. So 2x ln 8 minus 5 ln 8 equals x ln 5 plus ln 5. Let's move the x's over. Minus x ln 5 minus x ln 5. I'm going to change colors here into this sky blue here. Plus 5 ln 8 plus 5 ln 8. That's gone. That's gone. I end up with 2x ln 8 minus x ln 5 equals ln 5 plus 5 ln 8. Now what? Kylie? Factor out an x. 2 ln 8 minus x ln 5 equals ln 5 plus 5 ln 8. How do I get x by itself? Yael. Divide by the big thing. Kylie. Mm-hmm. Not going to cancel. Not going to cancel. Now, tomorrow on the midterm, I want you guys to keep this in mind. You need to show me the calculator ready in a box. Then you need to show me the decimal in the box. Okay? The reason for that is because if you end up with a calculator error and I don't see any work, like noticeable work that accompanies it, it's going to be severe points off. But if you give me calculator ready and I just think, okay, well, you know what? Sayana just maybe missed a button in the calculator, not a big deal, or rounding error happened, that's less points off. Okay? So, show me the boxes. We're getting to that in regular 3-4 right now, the box. So they know the box. Brother. I'm sorry? Box the calculator ready answer, and then box the decimal answer. Okay? Okay, let's take a look at some of these word problems here. 131. A substance decomposes radioactively. Its half-life is 32 years. Find the decay constant. Mr. Little, how are you? Good, thank you. Okay, everyone, listen up. A substance decomposes radioactively. Its half-life is 32 years. Where does 32 years go in this whole shebang? Jacob. Time. Okay, half-life. Guys, half-life. they're never going to give you A and P in half-life. However, give me a number and then give me something else. Brother. Okay, something easier than that. How about that? That's not bad. Something easier. Mark? 2 and 4. Okay, so if I have 4 particles of radiation, I'm going to end up with how many? 2 particles of radiation, right? What's E? E. What's R? Jacob? Who knows? What are we, that's what we're trying to find out, right? Okay, so let's set it up. 2 equals 4e to the R32. Nice car, by the way. The R32. Divide by 4. I'll say 0.5 equals e to the 32r. How do I bring that r down to the bottom? David. Take the natural log of both sides, so I get the natural log of 0.5 equals, what happens to the natural log of e, Matthew? Gone. Get rid of 32. And then r is going to equal, approximately equal something. Go ahead and punch that in your calculator and tell me what you get. Natural log of 0.5 and divide that by 32. As soon as you have the answer, go and raise your hand, please. Stephanie Boyer. Something slightly different. Brother. 0.02. Oh, sorry, thank you. Okay, all right, everyone, listen up. Everyone, go and quiet down, please. Thank you. Why would the rate be negative? Nikita. It's decomposing, right? It's decomposing. Good. So the problem should make some kind of sense. Okay. Next one, it says, let's do 134. For a certain bacteria, the growth constant is, actually, you know what? Sorry, timeout. For a certain bacteria, the growth constant is 0.775 when time is measured in hours. Guys, what significance does 0.775 play in this whole thing? Danny. It's the rate of growth. How long will it take for 2 bacteria to increase to 1,000? Who can fill in the rest of the information? Kaylin. Okay, that's the initial amount of bacteria. Okay. Okay. So, who can set that up in its equation form? Ryan. Okay, cool. So we know that's 500 e to the 0.775t. Oops, darn it. Equals. Sorry. Equals. How do I get that? How do I get that t down to the bottom? Alan, do you know how to get t down to the bottom? Natural log of both sides. Alan, nice job, dude. ln of 500 equals 0.775t. Divide by 0.775. T approximately equals what? Danny. Cool. One more problem. I want to do one that teaches you how to outsmart your calculator. Yes. Alyssa, this is about you, but your name is spelled wrong. I remember, you know what, when I was your age, Alyssa, $1,550 was a lot of money. Mr. Little, how fast can $1,550 disappear? In about, I made it disappear in about 2 seconds once. Okay, Alyssa deposits $1,550 in a. No, it was not gambling. It was paying my bills. Yeah, I mean, you think about car payment, you think about mortgage, you think about electrical bill, water. We're in a drought right now. My water's expensive, man. Okay, couple of things about this problem. One, you guys haven't dealt with a problem where everything is one-sided, which is going to happen in this problem. Alyssa deposits 1,550 into an account where it's compounded continuously. Where does 1,550 go? P, right? That's how much she initially had. E, that's a no-brainer. What is R? Okay, first of all, what's the most common mistake that I'm going to see when it comes to R? If this shows up on the midterm tomorrow, what's the most common mistake I'm going to see for R? Yael. I'm not going to take it out of the percent. It's going to be 7.25. Whoops! That's why you're going to end up with this really, really huge number. What is 7.25% as a decimal, Matthew? 0.0725. How much money is Alyssa going to have after 8 years? T is 8. That's a no-brainer. A equals 1550 e to the 0.725 times 8. Now people are like, wait a second, what am I solving for? You're solving for A. So people are thinking trying to move things to the other side. That's not right. A is already isolated, so now you just have to be smarter than your calculator and figure this out. Bam. All right? Cool.